Hey guys, so I'm going to go over homework first for direct and inverse variation. So again, these are things that are not equal. Y is not equal to X. They have some sort of constant of variation there. So every time, and I'm going to start with some odd, I'm going to write them out and talk through them so they become more clear for you. A is the variable, varies directly as the product of B and H. So varies directly means it's equal to, I'm not going to use A again. I'm going to use K as my constant here because that would be confusing with the different A's. So A is not equal to, it's equal to the constant of variation times the product of B and H. So KBH. It's all multiplied together. Varies directly means that it's in the numerator. These are in the numerator. I'm going to do the odds, and then if you have more questions, we'll go back through those. You can email me and ask me for directions for those, okay? All right, next problem. Y varies inversely as d squared. So d squared is obviously going to be d squared. Varies inversely means it equals the constant, not equal, but equals a constant variation, but inversely tells me that I'm going to put this information in the denominator. So I'm going to do this straight across. W varies directly as d squared. I'm sorry, it doesn't directly, it's inversely. Y varies inversely as d squared, which means d squared goes in the denominator. It means that as d grows, and in fact it's going to be squared, this value is going to get smaller. It looks like inverse. It looks like this kind of variation, as opposed to as x gets bigger, y gets bigger. So there's 3. Here again for 5, we've got varies. That means r is equal to the constant. It's inversely, meaning that everything after that goes in the denominator. It doesn't have anything fancy for t, just t. So r equals k over t. That's all there is to 5. For 7, it says x varies jointly. That means there's 2 things. As the cube of y and the square of z. There's no inversely in this problem at all, so nothing goes in the denominator. X varies jointly equals k. So the varies is the part that says equals k. The cube of y, so this means times y cubed, and the square of z times z squared. Basically, you go through the problem and change everything into math, only putting the things that come after inversely in the denominator. So 7, x equals k times y cubed z squared. Okay, 9 starts a series of different sort of problems. They're the same problem, but you actually have to work some math out. So 9 says, suppose y varies jointly as the square root of x. That's all there is to that. Okay, so y varies jointly. Oh, varies directly. Sorry, I was looking at a different problem. I was looking for another variable since I wrote jointly. So directly. Okay, sorry. Y varies means equals k times, we've already translated the square root of x into math, the square root of x. So this is the setup for the problem. They tell me one situation is that y equals 36 when x equals 16. So I've plugged those in. That's going to help me figure out k, which is the relationship. It tells me how they vary. It's the relationship for all of the situations that go with number 9. So when I solve this, I'm going to say 36 equals k times 4, divide by 4, k equals 9. Now put that back into my equation, y equals 9, the square root of x, and I have to find the answer to my question. In this scenario, this is the scenario, what is y when x equals 20? So I'm going to say y equals 9 times the square root of 20. So y equals 9 20 is 9 times the square root of 4 times the square root of 5. That's 9 times 2. Just going to go ahead and do that math out. 9 times 2 times the square root of 5 is 18 the square root of 5. So this becomes an ordered pair, 20, 18 the square root of 5. I don't know how they asked for the answer. They just told us 18 the square root of 5. You could do it either way. So this is a lot like what we did in Algebra 2, except we only have the one equation. This time we have to figure out what the equation is using direct variation or inverse variation. Plug in the values they gave you. Rewrite the relationship. This is the relationship. And then find the answer to their question. So there's number 9. Okay, so for 11, suppose y varies directly as the cube root of x. That is, y equals k. Varies directly isn't y equals something, it's y equals some constant of variation as a cube root of x. So I'm going to say x with a cube root. This is the general form where I don't know the constant of variation. This first set of information, which you're probably not writing all of the words out for your homework, which is fine. But maybe you should at least write, there's a point here, which is 125 and 75 are a point in this relationship. And I'm looking for x equals 5, and I don't know the y value. So that's my blank that I'm looking for. So I'm going to figure this out, figure out what k is using my given. This is the given, and this is the question. Y is 75. 75 equals k times the cube root of 125. 75 equals k, the cube root of 125 is 5. Divide both sides by 5. K equals 5 goes once and a 25, so 15. So that is not my answer. That is just how these numbers relate to each other in this situation. I have to go back and say that here's the relationship. There's my constant of variation. So these are related to each other by this factor. Now I'm given an x value, so I'm going to say y equals 15 times the cube root of 5. 5 doesn't have a cube root, so I'm just going to leave that like that. I wrote this problem down wrong too. So this really says when x is 128. Sorry. 128. Okay. So here we go. There's my relationship. Let me write it down again. Y equals 15, the cube root of, and now I have an x value, 128. So 128 is 64 times 2. This is 2 times 32 and a 2. 32 is 2 to the 5th times 2 squared. That's 2 to the 7th power. Okay, so let's see how that helps me out. I have y equals 15 times the cube root of 2 to the 7th. That means I'm going to say y equals 15, 2 to the 7th. 2 of them can come out. That's 2 times 2 is 4. And then I have 1 left over. So my answer is y equals 60, the cube root of 2. That's the y value. Okay, that's much better with the information they gave us in problem 11. Sorry about that. Hopefully by now you're starting to get the hang of this a little bit. And I have not written out entirely number 13. I have said the important stuff. Y varies inversely as x squared. I'm given the 0.43. I have to find y if x is 8. So I have shortened what I've written down on my paper. Probably this is about what you have. I wouldn't think you'd have much less than this because we're literally trying to start with something and get to an answer. You need to start with a problem. This is what I would expect you to have. So y is not equal to something, it's equal to some sort of variation of it. So I have a constant of variation. Inversely means that x squared goes in the bottom. Now I have this given information, I'm going to plug it in. So I'm going to say y is 3 equals k. K is not part of this, I don't know what k is. X squared is 16. That means that k equals 48. So my equation that's this circumstance, this y equals 48 over x squared, represents all of the ways that y varies inversely as x squared, with this being a point in that. So I have the right constant variation between these two values. Now when I work this out, I actually have to plug in 8. So I'm going to say y equals 48 over 8 squared is 64. And 8 goes into both of these. So that would be 6 over 8. So 16 goes into both of these apparently. That's going to be 3 over 4. So 3/4 for 13. They told me 0.75, but this is the same answer. You could have used 0.75 if you threw that in a calculator. I would hope that you wouldn't, that you could just go to 3/4 and be fine with that. All right, so we're still going. We're doing 15. Okay, in order to write 15 shorter, I used points x, y, and z. I'm given this information. Z varies directly as the square of x, or x squared, and inversely as y. So this is going to go in the denominator. So here's my equation. Z equals k, a constant variation, and directly as this number. So it's going to be k times x squared. Inversely as y means that y goes here in the denominator. It's very straightforward after you do several of these. Directly goes in the numerator, inversely goes in the denominator. And I have these three values to plug in to find out what my k, my constant variation is. Z is 36. K I don't know yet. X squared is 36. Y is 7. So I'm going to multiply both sides by 7 over 36 to get k by itself. I get k equals 7. Now k equals 7, what does that mean for z here? So my equation that shows all the variation between x, y, and z in this situation is z, not y, z equals 7x squared over y. Write an equation that relates the variables. There's the variables with their relationship in this situation. Now plug in z. I have z equals 7x squared is 144 divided by y, which is 21. Let's see, 7 goes into 21 3 times. 3 goes into 144. It goes z equals, it goes 4 times into 24, 8 times, so z equals 48 for 15. So hopefully this rings a little bit of bells compared to last year. We did this a lot, but we only did the one linear association. Now we're getting to plug in all different kind of equations. For number 17, they say z is jointly proportional to x and y. So z is not equal to, it is equal to k, that proportion, times x times y. And they're giving points that say that what if z is 90 when x is 1.5, z is 90, and y is 3. There you go. And then they said, what is z when x equals 0.8, y equals 7? So same as our last problems, we're going to plug things in and find out what k is. Z is 90 equals k times x, which is 15, times 3, which is y. It's not 15, it's 1.5. Sorry. So then we're going to divide by 3 times 1.5. So what is that? 1.5, that'd be 4.5. 4.5. 4.5. So I'm going to say K is equal to 900 divided by 45. I get lost in my decimals. I'm really good with fractions. I'm bad with decimals. So here we go. 45 goes into 90 twice, and there's a 2 there, so 20 equals K. Now I plug it back in. Z equals 20 times X times Y. I don't know what Z is. Z equals 20 times 0.8 times 7. And so we've got 8/10. Again, I'm better with fractions. 8/10. That means I've got 2. I've got 14 times 8. That's 32, 3, 112. Z equals 112 for 17. All right, and then we've got 19. That's the last of this group. 19 is a great problem. We've actually sort of seen it before, but not written in this format. So the distance that an object falls from rest when air resistance is negligible varies directly as the square of time. A stone dropped from rest travels 144 feet in the first 3 seconds. How far does it fall in 4 seconds? So this is actually how, when we found h of t equals negative 16 t squared, the gravity formula that we've used and we used recently, this is really where it came from. Somebody, Newton in fact, made different experiments to see what happened as things fell. They didn't know how to calculate gravity because it happened too fast. They couldn't do instantaneous pictures like we can do today. So here we go. We're going to write this out. Distance equals, varies directly, so it equals some constant as the square of time. So it falls, meaning nobody threw it. There's nothing after that. And we're just calling it the distance that it fell. So we're going to talk about distance over here. So here we go. A stone dropped from rest travels 144 feet in the first 3 seconds, 3 squared. So we're going to divide both sides by 9. 9 cancels 3 squared. And then 9 goes into 14 once and into 54 16 times. K equals the constant of variation, and that is what we found in the equations that we've used so far. We said h of t equals negative 16. This is written in a different way, so it's positive 16 because they're saying that it drops. So this takes in consideration that it's going down already. That's why this is not negative 16. And then we're going to find out what happens when d equals 16 t squared. How far does it fall in 4 seconds? So that's going to be 4 times 4, 16 times 16, 96, 6, 1. So that's 256. Distance equals 256 feet. So this is actually how it was figured out the first time. They measured it not falling straight down, but falling on an incline, something where they slowed it down and they could figure out how it went down a ramp and how fast that went. Number 20, CDs sold varies inversely as price. So inversely means that as things get smaller, the other value gets higher. They don't both grow. So here we go. The number of CDs sold, this is the number of CDs, so I'll call this number, equals K, because it varies, so it's not equal to, it has some constant variation, inversely as price. Plug in what they gave us, number of CDs and the price. 840 equals K over 15.99. And so we're going to find out our constant of variation. And we'll say 840 times 15.99. We're going to have a constant of variation of 13431.6. So what happens when the price goes down to $14.99? I don't know the number I'm going to sell, so I'm going to call this number equals my constant 13,431.6 divided by 14.99. So that number divided by 14.99 is going to be about 896 CDs. So number sold at $14.99 equals 896 CDs. 21 is a lot longer problem, but I'm writing down the heart of it. Your body mass index varies directly as the weight in pounds and inversely as the square of your height. Given a 6-foot tall man who has a BMI of 24.41, what is the BMI of a 5-foot 4-inch woman at 120 pounds? So let's see what we can figure out. We're going to call the first one B. Varies directly as weight, so equals K, because varies, as weight. Inversely is the square of height, height squared. Plug in what you know. Oh, this man weighed 180 pounds. I needed that. Sorry. All right, so body mass index is 24.41. We don't know the constant of variation yet. We know he weighs 180 pounds. And we know he's 6 foot, and we need to square that. But this says in inches, so it says height in inches. So we need to make 6 foot into 72 inches, 72 inches squared. So then we figured all that out. We're going to multiply by 72 squared over 180. 72 squared over 180. So that means when I multiply this part out, I'm going to have 72 squared times 24.41 divided by 180. 703.008. K equals 703.008. That's the constant of variation. So now I apply it to this person, and I have, I don't know the BMI, so I'm going to leave B blank. The constant variation is 703.008 times weight, which was 120 pounds. And then I've got 5 foot 4 inches, so this is 64 inches, 64 inches squared. So let's figure all that out. I've got the same constant variation times 120 divided by 64 squared. So her BMI is 20.596. Oh, they rounded it to 20.60. Either's fine. 21. Yay. 22 says the force that is necessary to keep a car from skidding as it travels along a circular arc. So think about you getting onto a highway or something. Varies directly is the product of the weight of the car and the square of the car's speed. So directly, force equals K. Product of weight and the square of the speed, speed squared, inversely as the radius of the arc, radius. Force equals the constant variation times the weight of the car, the square of the speed, and inversely is the radius of the arc. And then they tell us a bunch of stuff. So they tell us if it takes 241 pounds, 241 pounds of force to keep I don't know K, I know a 2,200 pound car moving at a speed of 35 miles an hour squared on an arc whose radius is 750 feet. Then I can find the constant of variation here. I'm going to throw all that in my calculator. So I'm going to say here, 241. I'm going to cross multiply times 750. And then I'm going to divide by 2200. And then I'm going to take that number and I'm going to divide it by 35 squared. You could write it all out if you wanted, but the constant variation is 0.067068. All right, so then they say, how many pounds of force? So force, I don't know. And then I've got my constant variation, so 0.067068. Should be actually 9 if I round right. Okay. How many pounds of force required if the car were to travel at 40 miles per hour? So it's the same car. So it weighs 2,200, but it's going 40 miles per hour squared. And the arc is the same, so it's 750. So some of the information wasn't given explicitly. I had to just know it was the same car. So then I throw all that in the calculator. I have this value times 2,200 times 40 squared equals, divided by 750, is 314 pounds of pressure. It rounds up. They gave us force is equal to 315. They rounded up pounds of pressure. All right, so those were the problems that were direct variation. I hope after going through these make a lot more sense for you. You can go and try some odd ones that we did not do. There's some sort of mixed in there. You can try some evens and come check my book so that you feel more comfortable with these. These are fantastic real life situations, noting that this is a direct problem out of real life. Y'all are driving, so you know that if you went too fast, you would totally skid out. BMI, you've heard about, so hopefully it's not something you're worrying about now because you're still teenagers, but this is a real situations with direct and inverse variation.